forgot my mic. Okay, so for the three of you on my right, you should be familiar for the first 20 minutes of whatever I'm going to do, which means that you should look very intellectual. But no worries, some of them I think equally lost, so don't worry, yeah, for the two of you on the other side. So I'm going to start off with this thing, which you have done before. Then I'm going to go to something that you have not done before, because this is the basic stuff you have to know. Everything else is a combination. So if I'm going to drop this thing, what's the only force acting on it right now? If I drop it at that moment. Come on. Sorry? mg, yeah, not gravity, mg, weight. Now as it starts to move, in real life, there's another force acting on it. Yes, correct. Now for the two of you, let's say, for example, you assume that the air resistance is kV. Come. Spread yourself. As I said to them, for the first 20 minutes, you should look very intellectual, because you should have done all these things before. Yeah? Now, the question is, can we use the four equations of motion? We can't. The problem is, because as you can see, the net force changes with time, because the velocity change. Yeah? So for the few of you over here, the one who are in my classes, you need to start. Can you do this for me? Derive the velocity against time expression without reference to whatever we have done. Do it now. Yeah? Do it on your own without reference to whatever you have done before. Get two expressions, v against t, v against x. Well, I go through with the two of them. Yeah? So no need to be embarrassed about this. Alright? No need to be embarrassed. Yeah? So mg minus kv, which is equals to air resistance, is equals to this. Can you see that net force is equals to ma? It's okay? It's arithmetic up to now. Okay? So therefore we call this A equals to G minus alpha V, where alpha is K upon M. Now can you see that A is equals to dV dt equals to G minus alpha V? Okay? This is the part. So you integrate from 0 to time, you integrate from 0 to final velocity V. Cool? Therefore, this is equals to T. This is going to be minus alpha ln G minus alpha V from 0 to V. Still remember your integrals? A bit lah. Okay, now you slowly get it back. Actually, it's minus 1 upon alpha. So therefore, minus, if we bring the minus alpha over there, it will be ln G minus alpha V upon G equals to minus alpha T. And therefore, 1 minus alpha upon GV is equals to e to the power minus alpha T. And therefore, V is equals to mg divided by k, 1 minus e to the power minus alpha T. Which the velocity time graph will look like this. And this is the terminal velocity that you learn in secondary school. Yeah? Okay. So must know how to derive this. This is the basis. What can change in the Olympiad syllabus is that I can give you this one as kv square or kx or whatever, but the steps is always the same. You always start from net force, get an expression for A, then dv dt. There's another method I will show you later on, and then integral. Okay? The method is always the same. I mentioned just now to some of you to find an expression for v in terms of x. I'm not sure how many of you have already done that, but let's take a look, yeah? Later on. I'll give you about 3 minutes to try not to look at this as you derive this. For the 7 of you over here, or the 6 of you over here, try to do it on your own. Once you're stuck, when you're stuck, then you refer to the board. Try to do it. No worries, it will not be everything that you have done before. There will be certain things that will progressively move on to unfamiliar territory. Okay? Now the next part of this equation is basically, the next thing I'm going to do is to, instead of coming up with an expression for v against t, how do I get an expression for v against x? So therefore you convert this from g minus alpha v to dv dx dx dt equals to g minus alpha v. So you use this thing called chain rule, I think? Chain rule? Yeah. So dv dx is equals to g minus alpha v upon v. Okay? Therefore v upon g minus alpha v is equals to dx dv. Now the problem is you got a v coefficient, you got a v over here, you got a v over here, so you cannot integrate easily for this one. So what you do is you break it down into this thing called partial fraction. I'm not sure how familiar with you is that, how familiar are you with this, but basically partial fraction is breaking this down into this. Then it's easier to integrate. Yeah? So how do you go about finding your a and b? This is what you do. You get ag minus a alpha v plus b upon g minus alpha v. So it's a g plus b minus a alpha v upon g minus alpha v. Now if you compare, can you see that if you compare the v term, minus a alpha is equals to 1. So a is equals to minus 1 upon alpha. If you do the same thing for b, you'll find that b is equals to a minus ag, which is therefore g upon alpha. Then you proceed on to do your integration, which will be the same form as what you got just now. Cool. Shall I give you a couple of minutes to try and integrate this expression from 0 to x, from 0 to v? So how the v changes with x. Ziyan, you okay? You look like your jaws are going to touch the floor. Am I right to say that all of you have okay with this? I wouldn't say okay meaning that you can do this on your own anytime, anywhere, but at least do you have any questions regarding the logical links from one step to another? For the ASP people, if this were to come out in your ASP exams, can get distinction or not? Can or not? Can get distinction or not? Exact same question, can or not? Yes, someone asking a question? Zhenfeng, you okay or not? You're like, what did I sign up for? Okay. Any questions? Nope? Okay. You take a look over here, try to derive the expression. Well, I give you another scenario. This one, I want you to develop on your own. Just now, I went through the full derivation. This one, I went through half of it, up to here, then you integrate on your own. I will do the solution later on over here, but what I want you to do is, if I were to throw a ball of mass m up with speed u, I would like you to find an expression of v against time. The air resistance is still equals to kV. Give it a try. What's the point of making alpha? Me breaking it, sorry?
What's the point of making what's the point?
A k over m, it's just that I'm lazy to write k over m again and again. Yeah. Yeah, it's plain. Yeah. Then after you get everything, then you just put back alpha. Give it a try. A good test of whether you kind of like, you can refer to the steps. You can refer to the steps previously. The difference between this and the previous case over here just now, what's the difference? Can someone tell me? Direction, exactly. So what's the directional change? Confirm 50% answer kind of thing. Either the magnitude or the direction. 50% chance. So can you tell me what's the expression for the net force? F net equals to, up to the point before it comes to rest, the net force is equals to? Anyone? Mg obviously and minus kV? Correct or not? Ming Guan, correct or not? Correct. Correct. Everything correct. Correct. Huh? It's kV minus mg. Where is mg acting? Up or down? Where is kV acting? Up or down? Down lah. It's moving upward. How can it move up and air resistance points up? Yes. So? Yes. Now I want you to do it yourself. Derive the expression. Can? And then after you've done this, try to do V versus X for this. Well, I write out the equation for this. Yep. Sorry? H. What H? This one. Oh, that's not H, that's lawn. That's lawn. Give it a try. Can. Can anyone just Google for me what's the small value approximation for ln?
Small value of
Yeah, correct. Or 1 plus ln. 1 plus x. Ln of 1 plus x.
So how did the dx then become a plus b?
Which one? How does?
Uh,
Which one?
The bottom equation on the left side.
Okay, okay.
How did the dx become a plus b over g minus alpha?
How does? Okay. How does this? You mean this becomes this? Yeah, I let it be. I let it be so that I let it be in a form where I can integrate easily. Yep. So it's basically for mathematical convenience, and it's partial fraction thing that whenever you have a function fx over fx of the same order, it is always the a, which is one order lower than the denominator plus another coefficient. But for Olympiad, you seldom have a denominator that is of v square. Usually it's of v. So you will be in the form of a plus b upon, yeah, g minus alpha v kind of form. Yeah. Have you learned partial fraction in math? You have, right? So basically it's partial fraction. Yeah. Anyone? Ln of 1 plus x, small value approximation.
Sir, this math tool we actually never learned. I know you've been using this right from the beginning. And I tried to check online, then I never found it. Then there was a while you stopped using this tool. So I conveniently forgot about it. Then today you picked this up again.
Okay.
So I asked about
Okay.
it.
Okay. Any small value approximation? 1 plus x.
This one, integration tool.
Just give me a minute, yeah.
For small x.
No, especially for ln. Where is it? So ln of 1 plus x is approximately? It's x. Okay.
Yeah.
It's x. Yep. Zero to t? Which one? You mean the right one or the left one? The left one, yeah? What about? No, I'm throwing something up. It's a different scenario. I throw something up. So then the speed starts to decrease. Yeah. So A is equals to mg plus kv. I'm taking downwards to be positive, so my u should be initially negative. Yeah. So dv dt is equals to mg plus kv divided by m, which is g plus kv. Therefore, dv g plus kv integral from minus u to v equals to integral dt. This is slightly more difficult because you're not starting from 0. It's not as simple. You're starting from a non-zero value. Oh yeah, sorry. It's alpha. Yeah.
So I'm not sure about the breakdown. So like how does d like dv is equals to dt?
Oh, okay.
That's how
Actually, what I'm doing over here is, you mean, how do I shift this over? So basically what I'm doing over here is delta v delta t equals to this. Then I shift the delta t over, then I make delta t infinitesimally small. Then it becomes dt. Yeah. So I'm not bringing the dv dt, the dt over straight away. I make it into delta v upon delta t. Then bring delta t over, then make it into a small, infinitesimally small change. Can? Yeah, also can. Also can. Yeah. Just that it may be misconstrued as I bring the delta t over. Actually, mathematically, I bring the. It may be misconstrued that I bring the dt over. Actually, I bring the delta t over. Okay? How people? Let's try. So we got t equals to 1 upon alpha ln g plus alpha v minus u to v. So it's 1 upon alpha ln g plus alpha v over g minus alpha u equals to t. Still okay? Yep. So therefore we have ln g plus alpha v over g minus alpha u equals to alpha t e to the power of this. Anything wrong? I'm thinking downwards to be positive, so upwards is minus u. Should I put a negative p somewhere? Cannot.
V equals to bracket g minus alpha.
This thing is the numerator.
Oh,
Yeah, that's the numerator.
the numerator is something over negative g.
No. The whole thing is the numerator. That means the negative g is part of the numerator. It's this minus g. Yeah. Okay. Is there something wrong? I mean, I'm doing this on the spot, so let's check whether there's anything wrong with this. This. Yeah. Yeah. Looks fine. Can you check whether for small values of e to the power x, is e to the power x equals to 1 plus x? Can you check for me? Small values of e to the power x. Can you check for me? Yes, correct. Is e to the power x 1 plus x?
I'm sorry, it feels right.
Just want to confirm.
Yes.
Yes, it is right. So v equals to, I'm just trying to check, e to the power alpha t minus g upon alpha is approximately g minus alpha u 1 plus alpha t minus g upon alpha, which is g plus alpha gt minus alpha u minus alpha squared ut minus g divided by alpha, which is equals to g, and this cancels off, alpha squared too small cancels off, which is equals to gt minus u. Does this make sense? Yes, it does. Isn't this your normal kinematics equation? Yeah? When e to the power x is small, that means time is small. The air resistance hasn't come in yet. Yeah? It should reduce to the usual kinematics equation, where the air resistance is not significant. Cool? Yeah. That's a good check. Now I leave it to you to try v to the power v in terms of x. I want to move on to something else really. From now onwards, it's not so much of differential anymore. It's you have to apply equations and to solve problems. Okay? But I think it is important for you to be able to handle this. Okay? Basic knowledge. For those of you who are done thinking about this, you have enough of integrals and you are vomiting integrals already. You can think about this. I've given this question to some of you before. Now, it's time for you and us to powwow this. Okay. Remember this? Okay, you've got two walls over here, one big height h, one small h. I project two projectiles horizontally projected, and it hits and it goes like this. They hit the same point eventually. The question is, what is the ratio of h is to h? 1/3. Everything 1/3. Everything 1/3. Unfortunately, it is not. Yeah, then 4/5. Then after that, Magnus effect. Then Bernoulli. Yeah. If you use Bernoulli principle, you get 1/3. Magnus effect, you get 4/5. Of course. May I know what deep physics do you use? Math. Yes, of course. Math, of course. Sorry? This one or this one? Then you try yourself lah. You try. Basically, the idea is e to the power x is equals to 1 plus x for small x. You try to derive it yourself. Come on, you can do it. That's all I use. And then the rest is really manipulation of mathematics already. Simple arithmetic manipulation. Algebraic manipulation. Seriously, like x plus y times x plus z. I'm sure you can do it. Okay, this question, you're supposed to find h upon h, small h upon big H. I'm not going to give you half an hour to do it. I'm going to give you about 5 minutes to think about this. Try, struggle through. How do you approach? Question you should ask yourself is, how do you approach? What sort of information can I squeeze out from the fact that they are projected horizontally? What sort of velocities relationship between the two objects A and B? These are questions you think about. All right? No point struggling for the sake of struggling. Think about those questions. How do you pull information about horizontal velocities? What's so special about the trajectory? What can you deduce from the trajectory? The fact that they coincide at the same point. What can you pull out? I'll give you 5 minutes starting from now. Then I'll come in to discuss. Because you have to go through that struggling process. Okay. Sorry? Oh, show me.
No, this is quite long.
3/4.
Although I think it's a bit long-winded.
T1.
guy
Where's
is
T1?
genius.
Where's T1? Where's T1?
This the time taken to reach.
Okay.
This.
Equals to V upon A. Where's A?
Oh, this one I didn't write down the thing. It was basically like the A is gravity, then V is the velocity, which should remain. Yeah. Okay, this one I just added up.
So basically, this time is the time taken for you to go here and come here,
Yeah.
which is the time taken for this to come down. That's your method.
Yeah.
Well, approach is fine. Answer is,
Correct.
we'll see. But it's correct. Yeah. So for the two of you, or for the one of you who solved it, For the two of you or for the one of you who solve it, think about, okay. If I were to fire something up here at an angle theta and an angle phi, find an expression for this, yeah, in terms of v and phi and theta, and find phi for max r. Two things. Since you have done it, try this. Varies. Last year it was 4, 5 questions, but with loads of parts. Loads of parts. And it's 2 parts. You can actually go 2 hours, break lunch, provided lunch. For some people, that's a key highlight. And then and then you got another 2 hours.
So if I had to pay,
You want to pay? You can contribute to the sustainability of the whole Olympiad exams if you want. It's okay, lah. It's okay. Yeah, sure. Yeah. So it's last year was held at NIE. It changed. Loads of parts. 5 or 6. Loads of like A, B, C, D, E kind of thing. Can. I'm sure that there are people who solve everything. I mean, seriously, in any school exams, even there are people who, whatever question is thrown at them, they can still get 90 plus on them. Right? Yeah. You got 2 more minutes. One more minute. Hey, hello. Yeah. The uphill task. Thank you. I think the assuming it's elastic collision at all points. Phi r is a theta. Phi r is a function of theta, phi, and v. Then find the phi for maximum r. What? Oh, that one you got to do differential. But theta is a non-changing, or theta is a rem or angle of the rem. So the one that you're changing is the phi. Yeah. So basically you're finding phi. Sorry? Trigo, yes, of course. Of course. There are 2 ways to go about. I'll show you both ways. Excuse me. Okay, for the first question. Now, first thing you need to deduce is that, can you see that the time it takes for A and B to hit the ground is the same? It means to hit here and here, they're the same because they're projected horizontally. Regardless of their horizontal velocity, the time taken to fall through the same height will be the same. That's projectile motion. Yeah? So therefore, I can deduce that VA must be equals to 3 times of VB. Why? Because this is 1 segment, 2 segment, 3 segment. That means in the same time, A travels 3 times the distance of B. You okay with that? Can I? Okay. Now, say if the time taken for you to go from here to here is time t. Yeah? Do you agree that the time taken for this to come to here is also t? Yeah? And if this is time t, this is time t, do you agree that this will be 3t? To reach the same horizontal distance, it must be 3 times the time. Therefore, if this is time t, this must be t and this must be t. Because the time taken for it to come here and here must be the same. Agree? So just by plain argument, logical argument. Therefore, can you see that the time for it to fall through big H is 2t. So if I use S equals to ut plus half gt square, it will be basically H equals to half g 2t square. And I take time t to fall through the height difference between H minus